Objective A. Solve a radical equation. Solve and check. Number 1. Radical m equals 11. The key to solve any radical equation is to isolate the radical part. So you just need to see where the radical part is and then perform inverse operations. Isolate that radical part. Number 1 is a good example. The radical part is already isolated. It's on the left-hand side of the equation. If you already isolate the radical part, all you need to do is simply doing the inverse operation on both sides. Since the operation on the left-hand side is a square root, we will perform the inverse operation of square root, which is square on both sides. On the left-hand side, of course, the square root and the square, they're going to cancel out, and we will have an m on the left-hand side. On the right-hand side, you simply perform 11 squared, that is 121. Of course, we have to check. It's highly recommended that you always check your solution for any radical equations. This is because when we square both sides of the equation, you might bring in invalid solutions in that case. So let's plug it in. Left-hand side, square root of 121. Is this the same as 11? If you perform 11 is the same as 11, yes, it is true. So we can conclude that our solution m is 121. Number 3. Square root of k plus 10 equals 0. So same thing, we're going to find out our radical part. Radical part is right here. We need to perform inverse operations to isolate. Subtract 10 from both sides. And we got radical k on the left, negative 10 on the right. And then we square in both sides because you have square root on the left-hand side. Don't forget to put grouping symbols. On the left-hand side, we have k because inverse operations. On the right-hand side, it's 100. Now let's check our answers. Radical 100 plus 10 is it equal to 0? So that is 10 plus 10. Is it equal to 0? Apparently it's false. So in this case, we will say no solution. Sometimes you will get expression that will not equal the other side, like this one. Therefore, our conclusion will be no solution. So that's why it's very important to always check your solution to a radical equation. Number 5. Radical n plus 3 equals 8. So same idea, our radical part is right here. We have to isolate this part. Get rid of that plus 3 by performing inverse operations on both sides. And we have radical n equals 5. Perform inverse operations again, we have to square both sides. And that will give us n equals 25. Now let's check our solution. Is radical 25 plus 3 the same as 8? Radical 25 is 5, so it's the same as asking you, is 5 plus 3 8? Well, it is true. So we could conclude that our solution is n equals 25. Number 7. Radical y plus 9 equals 3. The radical part is already isolated, so we simply perform inverse operations on both sides, which is square. On the left-hand side, we have y plus 9. On the right-hand side, we have 9. This is a very simple one-step linear equation. Subtract 9 from both sides to isolate our variable y. We obtain y equals 0. Check our solution. Square root of 0 plus 9, is this the same as 3? That's square root of 9. Is square root of 9 3? Well, it is true. So we could conclude that our solution is y equals 0. Number 9. Sometimes we have more than one radical part, like this. Good thing is the radical parts, they're on different sides of the equation and they are isolated already. So all you need to do is inverse operations on both sides, squaring both sides. So it's the same idea. You isolate one of the radical part and then you perform inverse operations. Make sure you put grouping symbols on each side. On the left hand side, you got 3x plus 7. On the right hand side, you got 7x plus 11. And by the way, the negative sign outside is removed because of the square outside. And now we have a linear equation which we can solve very easily. I'm gonna move that 3x to the right hand side, just simply, to cause positive coefficient of x. And the equation becomes 7 equals 4x plus 11. And then move that 11 to the left hand side. And I got negative 4 equals 4x. Divide both sides by 4, coefficient of x. And I got negative 1 equals x. Don't box your answer yet. Let's check whether or not if it's correct. Radical 3 times negative 1 plus 7. Is this the same as negative radical 7 times negative 1 plus 11? So you simply plug in the solution into the original equation. On the left hand side, if you simplify, this is radical 4. On the right hand side, if you simplify, it's also radical 4. However, they are not the same, right? Radical 4 is not the same as negative radical 4. If you're still not convinced, you could calculate 2 is definitely not the same as negative 2, so it's false. And our conclusion is no solution again. Number 11. Radical x plus 7 minus x equals negative 5. First, we need to isolate that radical part, which is right here. And that means we need to move x to the other side. So plus x on both sides. And then we got radical x plus 7 equals x minus 5. Now the radical part is isolated. We square both sides. On the left hand side, we have x plus 7. On the right hand side, I'm going to apply the formula for a minus b squared. X squared minus 2ab, that's 2 times x times 5, that's 10x, plus b squared, that's 5 squared, which is 25. We got a quadratic equation. To solve quadratic equation, you need to move everything to one side of the equation, 0 on the other side. The x squared has a positive coefficient on the right hand side, so I'm going to move both x and 7 to the other side by performing inverse operations. And that will give us a 0 on the left hand side, x squared minus 11x plus 18 on the right hand side. This quadratic formula can be solved using factoring very easily. Factor the right hand side, we will have x minus 2 times x minus 9. And then by applying zero product property, each of these two could be 0. So we got two potential solutions, 2 and 9. Now we're going to check whether or not these are correct. So let's check. Let me write down the original equation. So the first solution will be 2 plus 7 underneath the radical sign minus 2. Is it the same as negative 5? So that will be the first situation. The other situation will be radical 9 plus 7 minus 9. Is this the same as negative 5? And let's calculate for each of them. First one is radical 9, that's 3. So 3 minus 2, is it the same as negative 5? Well, definitely not. because 3 minus 2 is 1. On the other side, it's a radical 16, which is 4. So 4 minus 9 is 4 minus 9 negative 5. Well, yeah, it is true. Therefore, you could conclude that x is 9. Even though we got 2 solutions, but after we check our solutions, there's only one solution that's correct, which is x equals 9. So that's why it's always important to check your solution to any radical equations. Number 13. For radical x plus x equals negative 16. Identify your radical part, which is right here. So we're going to isolate this. That means we have to remove the x from the right hand side. Subtract x on both sides. We got 4 radical x equals, so over here I'm going to switch the order a little bit. Rewrite that as negative x minus 16. And then we are going to, so some of you might think that I need to divide both sides by 4. But in this case, if I divide both sides by 4, I will have a fraction coefficient of x on the right hand side, which I don't want to have. That's why I'm gonna square right now, and you will see why. So after I square both sides, I will get 16x squared on the left hand side. On the right hand side, apply the formula for a plus b squared. You will got x squared plus 32x plus 256. You could also use FOIL if you want. Once we have this, I'm going to move everything to one side of the equation. And by the way, the left hand side, actually I made a mistake. When I squared the left hand side, it's actually 16x, right? 16x. And then I'm going to move that 16x to the right hand side. So subtract 16x from both sides. The left hand side will become 0. The right hand side, x squared plus 16x plus 256. And again, it's a quadratic equation, which is much nicer. If you divide both sides by 4 first and then square both sides, it will look a little bit ugly, but you will still get something similar to this. What I'm going to do next is I will check the discriminant, which is labeled as delta. It's b squared minus 4ac. The b is 16, so it's 16 squared minus 4ac. 4 times a is 1, c is 256. And that is less than 0. You don't even need to calculate this. I think you should be able to tell that it's going to be less than 0. As a result, we can conclude that so there's no solution again. Strictly speaking, there is no real solution. You do have complex solutions, but since we're only discussing real numbers in this course, you could just say there is no solution. Number 15. Radical 9x plus 7 minus 3x equals negative 1. Very similar to the previous problem, right? Identify the radical part, which is right here. Inverse operation to isolate that. So we're going to plus 3x on both sides. And that will give us radical 9x plus 7 equals 3x minus 1. I always like to put the variable in front of the numbers, so that's why I switched the order a little bit on the right hand side. And now the radical part is isolated. We'd perform inverse operations on both sides, squaring. On the left hand side, we got 9x plus 7. On the right hand side, apply the formula a minus b squared. You will get 9x squared minus 6x plus 1. And now we have another quadratic equation. I'm going to move everything to the right hand side because the coefficient of x squared is positive on the right hand side. Subtract 9x, subtract 7. Subtract 9x, subtract 7. We have 0 on the left hand side. Right hand side, 9x squared minus 15x minus 6. Be careful, we have a lot of negative numbers here. before you continue, there's one thing that we can do. There's a common factor that we could take out on the right hand side, which is 3. So I'm going to divide the entire equation by 3 to reduce the numbers, the coefficients that we see. Left hand side is still 0, and then you have 3x squared minus 5x minus 2. It's a very common strategy to reduce the coefficients of quadratic equations. The reason behind that is to help you make better educated guess or faster educated guess. We're going to solve this by factoring. On the right hand side, I'm going to perform educated guess. Under 3x squared, there's only one choice, 3x and x. Under negative 2, if you try 1 and negative 2 and perform cross multiplication, you will be able to verify that this is the right combination, because negative 6x plus 1x, that is indeed negative 5x, which is correct. So you write your factor form horizontally. We have 0 equals 3x plus 1 times x minus 2. By zero product property, each of them could be 0. 3x plus 1 could be 0, or x minus 2 could be 0. Solve each of them for x. We got two potential solutions, negative 1 over 3, positive 2. Don't box your answer yet, because we need to check whether or not your answer is correct. Let's check the first one. So radical 9 times our x is negative 1/3 plus 7 minus 3x, so 3 times negative 1/3. That's the left hand side. Is this equal to negative 1? Let's calculate this. If you calculate this on the left hand side, underneath the radical sign, you should get negative 3 plus 7, that is positive 4. Radical 4, that is 2. And the second part, negative 3 times negative 1/3, that's positive 1. Is 2 plus 3 the same as negative 1? Well, apparently it's not. Let's check the other solution. 9 times x, which is 2, plus 7 minus 3 times x, which is 2. Is this the same as negative 1? Underneath the radical sign on the left hand side, 9 times 2 is 18. 18 plus 7 is 25. Square root of 25 is 5. Minus 3 times 2, that's 6. Is 5 minus 6 negative 1? Well, this time it is. It's true. Therefore, we can conclude that the second solution is valid. X is 2 only. And that concludes number 15. Objective B. Solve applied problems involving radical equations. On a clear day, the distance d in miles that a lookout on a ship can see the horizon from height h in feet can be approximated by this formula. How high must the lookout climb to see a ship 7.5 miles away? So this is giving you the distance and asking you for the height. So let's write down the formula first. D equals 1.2 radical h. And they already tell you the distance, which is 7.5. So you're going to replace that d with 7.5 and copy the rest of the equation. And now our job is to find out the value of h. It's just solving the equation. First thing to do, identify the radical part, which is right here. And then we're going to do inverse operations, dividing both sides by 1.2, which is the number outside. So I'm going to divide both sides by 1.2. The right hand side divided by 1.2 as well. The left hand side, if you use your calculator, you're going to get 6.25 equals radical h. And then perform inverse operations on both sides, squaring both sides. We will have 39.0625 equals h. And that is the height. So the unit is feet. Therefore, the height is 39.0625 feet. That will give you a distance of 7.5 miles. That concludes this section. Thanks for watching.